This year, I did my first ever interview, and the best part was that I interviewed a very talented Mexican astronomer named Svea Hernández. I have known Svea for many years since she started working at the Space Telescope Science Institute in 2012 as a research and instrument analyst, and now, after taking a detour to get her PhD in astrophysics, as the deputy of the Cosmic Origins Spectrograph branch. Working at the same place allowed me to have a direct conversation with her and share her remarkable journey through the Oasis del Norte in Coahuila, Mexico to Baltimore, Maryland, working with one of the most productive space telescopes of today, the Hubble Space Telescope.
Thank you, Rosie. It's a pleasure being here with you, chatting about the different paths, right, that each of us might take throughout our careers. So yes, I was born and raised in Mexico. Actually, I come from a very small town in the north part of Mexico. The name of the town is Musquis in the state Coahuila. And so basically this tiny town is almost bordering Texas.
Melchor Musquis, Coahuila, or Musquis as it is known, it is a small town of just about 30,000 inhabitants and known as the Oasis of the North and considered one of the pueblos mágicos of Mexico. It is situated on a small tributary of the Sabinas River, roughly 1,600 feet above the sea level and next to the Sierra of Musquis. Because of the remoteness of this town and low-level light pollution, it offers beautiful views of the night sky, which Svea recognizes didn't appreciate until she was older.
Actually, even growing with that proximity to such clear skies, interestingly, I didn't start developing like this passion for astronomy until I was in high school. So I was around 14 years old, and in high school, they took us out to a camping trip on a weekend. And it was the simplest thing. One of our teachers brought a pair of binoculars. And so we were all looking through the binoculars, the simplest, again, objects. We were looking at the moon, and we were looking at Mars, for example. And I remember appreciating the detail that such a simple instrument was allowing us to see on such an object like far, far away from us, like it's Mars. Mm-hmm. And being able to see some of the structure of the surface on this other planet. Something in me triggered, and I just started asking questions. Wait, but how can we appreciate such detail with something so simple? And then the teacher started expanding. Oh no, but if you use like larger telescopes, then the distances and the detail it's magnified. And I think that weekend I remember being kind of like the trigger point. After that, I did not stop asking questions.
That's it. Okay.
And yes, and later on, I think like 1 or 2 years later, I, again, searching for a career path, what can I do? I was surprised that I can actually get a career studying the objects above us, like studying at stars, how they form, galaxies. And once I learned that I could get a bachelor's in science to do that, there was no way back. And so after high school, I started getting this like tiny, tiny dream that began growing of, I want to work for NASA. I want to work with the big telescopes that NASA has. And so in my mind, to be able to end up at NASA, I had to come to US to study. And so after high school, I actually moved to Texas to start my college studies for a bachelor's in science and astronomy.
And let me ask a question. When you were in that stage, did you know about the Hubble telescope?
Actually, no. And so that's one of the differences that I always spot, talking to our colleagues, other astronomers, depending on the age, different things got different people into astronomy. And a lot of them is like, the first images of Hubble, which came, in the early 1990s, which I was a child then, but I did not hear about Hubble until I moved to US. Is, also, I moved to US in 2006, I believe. And internet, again, coming from Mexico, we had access to internet, but it was not as, widely accessible as it is nowadays. Yeah. So Hubble images, they got to me very, very late in time. But of course, once I started learning more about, the power of all the different like technologies that NASA had made available to astronomers, then yeah, again, it was just like this explosion of passion and curiosity for learning more about that.
Yeah, that's great. So you said you moved to the States. You had family that was in here, your father, right?
Yeah. So my father was a naturalized U.S. citizen. But interestingly, the whole time we lived in Mexico, and he would just commute like once a month or something to go back to Mexico to see us. And so really growing up, we never considered moving until, again, I got to the stage where I needed to go to college. And for me, that was the option. Okay, I want to end up at NASA. And it was the first time I remember mentioning to my mom, hey, I think I want to try this, but to do it, we need to go to U.S. And actually, we moved, the whole family, that time we moved together for the first time to Texas, so I could attend college here.
So which college did you choose?
Yeah. So again, I did as much as research as I could, but it was not very thorough. However, I did learn pretty quickly that the astronomy department at the University of Texas in Austin had a very good astronomy department.
Definitely.
A lot of research, active research going on, and I didn't have to go far. So I put my materials together, submitted my application, and again, I've been very, very fortunate along my career path. And that was the first step towards achieving, a career in astronomy and astrophysics, and they accepted me to their program.
You didn't go to the PhD right away, right? You took steps in between before you went to your PhD,
exactly.
Right?
So I took a minor detour, and just to expand a little bit more on that, so in my last year of college, so the traditional path for astronomers that want to get a PhD, a doctorate, is once you finish college, then you sign up for grad courses or graduate school, which is an entirely separate process. And typically in astrophysics and astronomy, getting your PhD after your bachelor's takes around 6 years, which should include a couple years of master's. And so back then in my last year of college, I was aware that, okay, if I am going to go get my PhD, that's a very, very strong commitment. That's 6 years that, you don't work in the industry, you don't get paid comfortably. So I knew that if I wanted to take that step, I needed to be 100% sure that that's the career that I wanted. And so in that last year, I started searching everywhere for summer programs or opportunities that will let me learn a lot more and hands-on on what it is to be an astronomer. And I remember I applied actually for a summer program here at Space Telescope. That was in 2010, I believe. And only actually one program accepted me, and that was just because I started emailing everyone around the world. Once I got the official rejections from the official programs, one of my professors said, you know what, Svea, like if you don't want to waste your time, 1 year gap, then you have to start reaching out. Start emailing astronomers at different institutions, professors all over the world, and that's what I did. And again, I go back now to my Hotmail account, and I can see all the messages sent, and it was more than 50. And out of those emails I sent out, there was one response from an astronomer at the Gemini Observatory in Chile. And he said, oh, Svea, it's great that you're actively looking for an opportunity. We might have something for you at Gemini, but it's going to be at Gemini North, which is in Hawaii. And so he said, send me this and this additional information. And then he put me in contact with the astronomers in Hawaii. I had a couple of interviews, and they said, you know what, we actually need a lot of help. So yeah, come help us out. And again, I was very fortunate. That was the second step where things lined up so perfectly, and so they allow me to work as an intern with them at the observatory in Hawaii for around a year. And that was, again, one of the most incredible years, because I really submerged myself in the astronomer life. I was interacting with engineers. I was up on the mountain observing once a month. Going out to lunch with the astronomers themselves, with the postdocs, and really embedded in this like scientific environment. And sure enough, after a few months, I decided, okay, this is what I want. So let's move forward with this. Yeah,
that's great. I mean, I think you said that you were lucky, but more, I think you took the right steps. You got a good advice from your professor, just telling you apply and reach out to people in order to find something.
And so actually, one of the things I feel that I started learning, thankfully early enough in my career, is a lot of the times either we get advice or we're considering a particular situation and we have we put in front of ourselves like different options, and then we actually look at those options and we're like, no, these options are most likely not going to get us anywhere. And so I learned that even when we feel that way, just jump ahead, like, because many of those times you actually get a reward much larger than you ever imagined you could have gotten. Definitely. So definitely just every time just jump ahead, and if it doesn't work out, we move on to a different direction. But again, every single step along the way in my career, I've tested that theory and it has proven right.
Wow, that's good. And then after that, then you came directly here to Space Telescope, or
yes,
what happened?
So that was another hiccup. So I was in Hawaii, and once I had decided, okay, this is what I want to do with my life, I started applying to different graduate programs here in U.S. And turns out that there was a visitor scientist in Gemini who was the director of the university, the astronomy department in Spain, in La Palma, which they also have a big astronomy program because they have telescopes there. And one of my colleagues mentioned to this professor, oh, we have an intern here that's actually looking for programs and to go get her PhD. And so I had a quick chat with him, and he said, look, based on your instrumentation background, the year that I had spent in Hawaii, he said, you're going to do excellent in our program, so I invite you to apply. I think, you're going to get in the program right away. And so starting like balancing things out, and of course I thought, well, Spain, starting like branching out outside of US. So I went ahead and submitted my materials. I was accepted to the program. But again, the program is the first 2 years, it's a master's, so you get full courses for those 2 years, and then the remaining 4 years is the PhD work, which is research. So everything was fine. I actually notified the Gemini people, okay, I have to go because I need to make preparations to go to grad school. So I left my internship in Hawaii and went back to Texas to get all the paperwork ready. So things got very, very delayed on the Spain side, and when I needed the documentation for the student visa, they just took forever. Yeah. So yes, because some systems are more delayed than others. And so I received the documentation, I remember, I think it was in October, and the classes had already started in September. And so, the department was very apologetic and said, hey, we're so sorry for the delay, but we're going to keep your spot for next year, which it was excellent, except I had nothing in between. In that year, I had left my internship in Hawaii. And so, I thanked them for the opportunity, but then I started scrambling. Again, I was with no options in front of me. And so I went back again to look for positions available in astronomy, because I didn't want to, if I was going to take that gap, at least something related to astronomy. And that's how I ended up here in Space Telescope in 2012. So I remember I applied for a research and instrument analyst position here. Again, I went through the process of submitting applications, a couple of interviews, and they extended me an offer. So I started as an analyst here in January of 2012.
And how many years was that you stayed in here?
Right, and so I accepted that position, and I remember even during the interview, because they asked, oh, where do you see yourself in 5 years? And I was true. And told them, well, I plan to go to grad school, so I can be here. I plan to stay here for maybe a couple of years and then moving on to grad school. And, they were fine with that answer. So I stayed in that position the first year. And I being submerged again in like this scientific environment, learning so much about programming, about how the telescopes work. I was directly supporting a couple of the instruments on Hubble. And so at the end of the first year, I said, okay, I'm going to stay one more year, but so, I can actually contribute in this 2 years. And so at the end of the second year goes by, and I'm enjoying the job so much that I said, okay, let me stay one third year. And towards the end of the third year, I said, okay, I need to leave now because the job is just so incredibly
it's rewarding.
Yes, rewarding and enjoyable that if I don't leave right now, I'm not going to get my PhD. So I left after 3 years, and I left for Europe. I moved to Europe, to the Netherlands, to for real now start working on my PhD.
And well, one of the things common in here in this job, as when you and I know that many people come to this position that you took sometimes to make the same decision that you made. It's just a step, and that's expected in here, just people that have that experience with you had. But then at that time, you also had an opportunity to figure out what field of astronomy you wanted to pursue, right? Because there are so many. I mean, you have to choose something in particular.
Right. Yeah, no, again, going back to, I really have felt very fortunate because the 3 years that I worked here at Space Telescope, I grew professionally, intellectually so much, and that gave me an opportunity that many other people don't get to experience when they follow the traditional path, right? You finish college, you go straight into grad school, whereas with the 3 years of experience I had here, I actually interacted not only with astronomers, and I was doing research with them, but also interacting with postdocs, which is a different stage, but just knowing what it takes to remain in astronomy. You need to work really hard. You need to publish papers. You need to be aware of the quality of the research you're doing.
Yeah.
And so I remember after leaving the institute and going and starting grad school, I could compare my approach to writing papers, to analyzing data, to the approach of my colleagues and other students in grad school. And it was very different because I had gone through this experience. Like, I knew what to do when reducing observations. I knew what to do when writing an introduction, describing the data analysis, which again, and that was all thanks to the experience that I acquired in those 3 years here.
Yeah, and I can relate to that. I mean, going myself through that and not having that experience that you had. Yes, just sometimes you depend on your advisor, but then you already have had this experience in here working with people, which is great. I mean, set up more for success rather than you just to be navigating without knowing what to expect.
And it was, going back to your comment about, being here, I got to contribute to different research fields. And by the time I left the institute, I knew, okay, I want to do analysis of spectroscopic observations, of measuring the chemistry of different components in a galaxy, because I experienced that approach and what it takes to do those types of sciences here, which again, it just perfectly prepared me for the next stage.
And how many years did it take you to complete your PhD?
So that's another good question. So again, I worked as an analyst here for 3 years, and I mentioned earlier, a typical PhD program is 6 years. In US, it might take a little longer, 2 years of master's, 4 years of the actual research graduate work. And so when I applied to this particular program in Europe, it was also an extensive process where they review your application, they have to interview you, you have to give a talk about a particular research field. And after I went through the whole process, they got back to me and said, actually, so we saw, all of the experience you're bringing to the program, and so we're going to grant you automatically the master's.
Well, that was great.
Yes, because of the experience that I brought with me, being collaborator on scientific publications. And so basically they admitted me into that program, and the program itself, the remaining of the program would be 4 years. Again, giving the experience and how just like the view that I already had about the field and research. I actually finished 3 years after my PhD. I was handing in my thesis, and I defended 3.5 years later, and I was back here before 4 years.
No, that's great. I mean, that what you
a lot of time, and also, I mean, that was really, really very helpful. No, that's great. I envy you.
Yeah, I'm telling you, I've been very fortunate every step of the way.
That's great. So then you came back here. Well, but you also had to apply to jobs in here, and getting jobs in astronomy is very difficult. So how did that work for you?
Yes, yeah. So one of the reasons I wanted to go to Europe after here is because I felt that I had enough scientific collaborations or connections, if you will, with astronomers in US. So in my mind, the strategic approach would be, okay, I want to go to Europe and establish collaborations there, which that's what the graduate program gave me. Once I finished the PhD, again, I really had enjoyed so much working here at Space Telescope. Again, the science atmosphere is just so alive, and always something happening and keeping you on your feet, that I really targeted the institute. Any options or postdocs that they were available, I applied to, I think, like 3 different postdocs after my PhD, and then I applied for 1 more postdoc in California. And I was interviewed for all of the positions that I applied for, and Space Telescope, for one of the research projects, they offered me the position. So soon after, I think, so I had officially finished in July in the Netherlands. But again, I was like done with thesis and defending like way before then. So I moved back to Baltimore, and even before starting my postdoc position here, I was able to start working on the project much earlier. Mm-hmm. And so I was a postdoctoral fellow here from 2018 to 2020. Again, I enjoyed every single second of that experience. And then on my last year of that postdoc, I started searching for the next step. Mm-hmm. Again, as you mentioned, it's really, really hard in astronomy to find that next step after the postdoc. But given that I had worked at the institute in different positions, right? First as an analyst, then as a postdoctoral fellow, I applied for an astronomer position here, funded by the European Space Agency. Again, going through the whole process, and in 2020, again, I was fortunate enough that they sent me an offer, and I transitioned into astronomer then. Yeah.
Then, no, that's great. I mean, that's so wonderful to see that. I mean, the steps that you took, I mean, I think they just set up for this success. And of course, you are very bright, and you have to be bright to also be able to do it, right? And you demonstrated that, and people wanted you.
Yeah, I think part of it, we all have like struggles with imposter syndrome, but one of the things that I do know for sure that has helped me, every step of the way is like just working really hard. So, I think, a fraction of the successful equation is working really, really hard, but you also need to be a little bit fortunate. And someone told me once that by working the hardest you can, you are helping your fortune yourself, right? So you naturally position yourself to get good opportunities. But again, you have to pay your dues and sleep late and work hard. But that's part of why we love this job.
Yeah, and I think another aspect is that where in the steps that you took, you got to know the community. You gave yourself to the community, and sometimes getting these positions depends on who you know. Mm-hmm. So I think that is also very important to build relationships with the people on your field, and the institution that you did with the Space Telescope when you were working here, which is very important.
Yeah, and I think, a lot of the times we're not aware of who's watching when we're working. Yeah. But this is why it's so important to like give your best, because sometimes you don't know who you've impressed that might give you a big opportunity in the future.
Yeah, so now what is your role here in Space Telescope? I know that or we know that when you're working in here, not everything is science. I mean, you have to divide your time between science and what we call functional work. Mm-hmm. So we will talk about your science, but I want to talk a little about the functional work that you do here at the Institute.
Sure. So as an astronomer, the position, like you mentioned, is split in science and functional. And in my case, it's an even split. So 50% of my time I dedicate to independent research, and 50% it should be to service to the Institute. And in my case, I am currently, since I took this astronomer position, I joined the much larger group of astronomers and scientists supporting the Hubble Space Telescope mission. And it's been actually incredible to be part of this team just because of the heavy and impressive history that Hubble comes with, right?
Yeah.
It's a telescope that is 33 years old, and we're continuing to do incredible science with it. The instruments are still working hard. And so being part of the group of scientists that keep those instruments going and keep pushing the limits of the different configurations of all of these instruments to even newer regimes, it's just very enjoyable to be part of that effort.
And one of the things that people do not realize, that it's very important that people like you that is knowledgeable about the instrument itself, you are supporting other science. Because,
Right.
I mean, it is not like the telescope takes images and that's it, right? You need a strong team of science and scientists that understand how the instrument work, that make sure that it keeps working well, and that the scientists get the best data possible.
Yeah, exactly. And I think one of the really, really critical strengths of the Institute is having astronomers and scientists that we're active doing science and research, is that we know where the different fields stand, right? So we know, okay, if we were able to do this particular technique or method with this instrument on Hubble, and so we work towards achieving those goals. So we know what the community needs, because a lot of the times is what our research needs.
Yeah.
And so I think it's the best, most magical synergy when we can help, like you said, the community push the science limits to new regimes. And at the same time, we are helping our research. So it's just the perfect combination.
That's great. So let's talk about your science. I mean, I actually was looking to the title of one of your latest papers that you published, that it was dissecting the infrared light of M85, right? I think
M83, yes.
M83,
yeah.
sorry. M83, and it sounded very, I don't know, dramatic.
Yes.
So tell us a little more about that aspect of your research.
Yeah. So I actually, for my science, I have used some of the biggest telescopes on the ground, like the Very Large Telescope in Chile, but also the big telescopes in space, of course. So I have used extensively the Hubble Space Telescope, and in a study that we did in 2021, I believe, we started seeing some like weird signatures in our observations. And to better understand what was going on in this beautiful spiral galaxy that is 15 million light years away from us, to better understand what we were observing with Hubble, we decided to actually use the newest telescope, James Webb Space Telescope, in the mid-infrared. So that's one of the wavelength regimes that are very unexplored, especially at the sensitivities and the resolutions that Webb gives us now. And so we decided to submit a proposal, and they approved our project. So our project is based mainly and focused, particularly the paper you were mentioning, on studying the heart of this spiral galaxy. And just to give a context for the James Webb observations, which are shown here on the right, the information here that we see in this like rectangle basically come from this much smaller area in the spiral galaxy we're studying here on the left. And you can see is this galaxy I mentioned before, 15 million light years away from us. And what we're studying is basically this much smaller region, the very, very heart of the galaxy. And one of the reasons why we're interested in this region, as I mentioned before, is because in this particular area, the galaxy is forming a lot of stars at a very fast rate. And at the same time, these very, very massive stars, they began to irradiate. So basically, the radiation from these massive stars begins to warm up anything that's nearby. And so with the James Webb observations here, again, in the probing the heart of the galaxy, right now here we're stepping at different wavelengths, which basically gives us information on different components of the galaxy. You can see that the brightest regions, so they have very different diffuse structure, but there's also parts that are much darker. And as we were saying before, so these observations from James Webb not only give us information on the molecular gas, but we can also learn about a different type of gas, which is in a different physical state, which is the ionized gas. And this ionized gas is actually much closer to this massive stars. And again, just to put the observations in context as well, the regions that you see where they're very, very bright, so they're on top here, and then you see maybe like circular structures, more or less, roughly here, spherical structures. So those are the locations where the massive, massive young star clusters are, which are shown here, which again, this is more or less a zoom in of, but this is a Hubble image telling us or giving us information on different things. But those 3 points, for example, this very bright dot, those are the massive stars that are heating up that gas, this luminous regions that you see there.
And that image in there, it is in the visible ultraviolet light, right?
That's correct, which is what we get with Hubble. And just to close the loop on that, we know that with James Webb, we're obtaining, I was mentioning, we get different pieces of the puzzle. And with Webb, these particular observations are in the mid-infrared. So those are wavelengths that the Hubble Space Telescope cannot detect or observe. But this is why combining observations from different telescopes allows us to, let's say, begin understanding the puzzle of star formation in different galactic environments.
And that blue circle that you have in the top, corresponds to this
exactly
region,
yeah
which in there is very
not so bright.
Not so
yeah
bright
exactly whereas here because the mid-infrared observations are giving us the spatial distribution of the gas, and here in the optical what you see is basically clumps of stars, of very young stars, and so you see almost a point source there. Whereas here in the mid-infrared observations, you see diffuse emission, which is the gas, as opposed to the stars that you see in the optical.
And what is that flickering that you see in your images?
Yes. So that's the trick with our data reduction. But as I mentioned, so we're basically stepping on different wavelengths or colors, even within the mid-infrared regime. And so at every different wavelength, then the calibration that we apply is slightly different. And you can see it's every now and then, very black pixels come up, and that means that the calibration was not as optimal in those regions. You can see on the edges here, for example, those are like the edges of the detectors. So again, the calibrations vary a lot more as opposed to the more stable regions in the middle of each of those squares. This particular, again, as we're scanning, you can see, which this was one of the things that as astronomers is so impressive, like you can see this diffuse emission of the gas in structure, like almost outflows of gas circling in this very, very aggressive, we would say aggressive environment, because there's so much going on. Stars being formed, these very massive stars also generate winds, and those winds again impact all of this gas. Yeah.
Yeah, and one thing, just to clarify, and the type of detector that you are using is each image is at one wavelength, or is a type of light, and then the same region maybe slightly differences because of the size, but you are stepping. Each of them is a different
wavelength, which is basically a different color. And again, different colors give us different pieces of information. On the molecular gas, on the ionized gas. These observations also we're using them to study the dust in this environment.
And in here is you can see where it's stepping in the wavelength.
And the different,
so each one like this. No? Perfect. Oh, this is very, very interesting. So you are going to continue studying this type of environments, type of galaxies?
Yeah. So I was mentioning that we're trying to understand how exactly star formation proceeds in this particular environments, which are unique in a sense. Again, being in the heart of a spiral galaxy, there's so much going on, so much activity, so much radiation. And so we're hoping to move this project forward not focused on a single target like we started with this pilot project, but in this last cycle where we had to propose new projects for James Webb, we actually sent out a proposal to perform a similar study to look at the properties of the molecular gas, but in different galactic environments. So this pilot study focused on the spiral galaxy. In the new project, we're hoping to study a lot more different galaxies, particularly compact galaxies. The smaller, tinier galaxies, they actually have star formation at higher degrees. So they're forming stars much faster than say, for example, this galaxy is forming on the spiral arms. And understanding how star formation proceeds in different galactic environments, that's basically one of the big questions in astrophysics.
Well, thank you so much for the wonderful explanation, for sharing with us your story, and also you gave people or young people that are interested in this field wonderful advice of what to do, what are the right steps to make their life easier in the long term. So thank you so much for that. I appreciate it, and for sure we will come to visit you other times so you can tell us more about all the research that you are doing.
Please do, and thank you, Rosie, for leading this sort of initiatives that I'm excited to contribute to, and we definitely need people like you to help us spread the word about the incredible science that a place like Space Telescope does. Thank you so much.
And also more the people that makes it possible, like you.
Thank you.
So thank
yes.
you.